Welcome back, physics fans, and we're going to go on to lesson 3 of this chapter, and that is relative speed. Okay, and it is not how fast your uncle drives, even though that's a relative, and there's a speed involved there. Relative motion is, here's our definition, is the difference in velocity between two objects. Okay, the difference in velocity between two objects. So difference here is the mathematical term. When we often say what is the difference, and this is the answer to subtraction, is the difference. You don't have to know that because I'll teach it to you on how to figure this out. Okay. In actual fact, it's impossible to have a velocity without comparing it to something. Okay. For example, a car that's moving 60 kilometers an hour is read from its speedometer that's referring it to the car's motion compared to the road. But the road really isn't stationary. The whole planet's moving. So when it's relative, we have to know what it's relative to when we measure a speed. Okay? This concept may be confusing. So that's why we have a lesson on it. The easiest way to determine the relative speeds is to imagine that you're sitting from one observer's point of view. So we have two cars here going towards each other. We have car A and car B. But how do you know what their relative speed is? If you look at this guy, is he coming faster than this? You have to figure that the, right? You have to kind of look at what he is seeing compared to this. But sometimes, and that is very difficult to do, try to imagine what one is seeing. Okay? So this is challenging. Okay? Challenging. So, how do we do it here? This is going to be quickly. I'm going to say that if the two cars are moving towards each other, so that means an arrow this way and an arrow this way. It also works for if they're moving apart. So if they're moving apart or they're moving towards each other, you add their velocities. So if this is 35 and 15, we would go VREL, the relative velocity, is equal to 35 plus 15, which is 50 meters per second. Okay? And if they ask, what is the direction of that velocity? And we say yes. It's both directions. To this guy, the velocity is this way, and to this guy, the relative speed's that way, or vice versa. Okay? So we add them. But Mr. Curl, you said it was a subtraction. Answer to subtraction. How can it be a subtraction if we're adding? Okay, this is the logic behind it. Please don't copy it down. It's not necessary. It's just good for understanding. This is east, this is west. So it's going to be 35 subtract a negative 15 because they're opposite directions. We're going to call this positive. If that's positive, then this is a negative speed, 15 and 35, opposite directions. So we're going to be subtracting. We are subtracting, but it's a negative, so we literally add. Okay, but my rule here is if you're going in opposite directions, so example there or an example here, you add. Okay, so from one viewpoint of car B, it would seem as if car A is moving towards him at 50 meters per second. So the relative velocities are 50 meters per second. Okay, and it's just confirming here that if it's opposite direction, we add their velocities. Just draw a nice line here because we're now changing suit. We're going to the opposite side. If the two objects are moving in the same direction, we actually subtract their velocities. So what does same direction look like? This is same direction. Okay, it could also be same direction, but those two examples of same direction. So if we are in the same direction, we subtract. So we would write down VREL is equal to 35 minus 15. and get 20. Okay? I will occasionally get the questions, which one do we subtract from another? Because that makes a difference. When we add, we'll always get the same number, right? 35 plus 15 is the same as 15 plus 35. But when we subtract, one will be negative, one will be positive. If we swap it around, 15 minus 35. And that's okay. We're always going to do relative 20, and the answer is plus or minus 20, depending on who you're looking at. So my rule is take the bigger number, subtract the smaller number. It's easiest. So this is how to calculate the relative velocity. What do we use it with? Well, we already in lesson 1 had v is equal to d over t, constant velocity. In lesson 2, we have average velocity is equal to total distance over time total. And in lesson 3, we're getting the relative velocity is equal to the relative distance over the time. Okay? But as you can see, the similarities here is that we might go vrel is equal to drel over t, or we just simplify each one of these as v equals d over t, and just know the rules for each one. This is lesson 1, constant velocity, average velocity, and relative velocity. Much ado, let's swing on over to the back and let's try a question with this. Nathan. Nathan is running at 6 meters per second and is trying to catch up to Michaela, who is 150 meters ahead and is running at 4 meters per second in the same direction. A, how long will it take for Nathan to catch up? And B, how far has Michaela ran during that time? Okay, so let's just show you. Let's do, Nathan is standing here and about to run. And Michaela is already over here. Flowing hair in the air. There we go. And there's 150 meters between them. Just trying to picture this. They're both running. She's running this way at 4, and he's running this way at 6. Okay, and eventually she's going to run to being over here. Hair flowing, and he will have caught up with her. So he's going to be right there as well. Okay? So, we don't know this distance traveled. That will be the answer for B. And we don't know the time that it took. So, where do we start? Well, if it's two different people or two different objects moving at two different speeds, we instantly start with this statement. VREL. Why do we start with that statement? Because this is a particular question and you want to get marks. It's on a quiz, it's on a test or something like that. You read the question, you see two people, two speeds, you instantly go, it's a relative velocity question. To get marks now, you have to tell the person who's marking it, you have understood it to be a relative velocity question. So what do you write down? You could write down the sentence, this is obviously a relative velocity question with two different speeds of 6 and 4, or you can write this down. VREL equals the larger one, subtract the smaller one, and equals 2 meters per second. And then at that point, I'm showing you, I'm boxing that off. This is how you show the marker, me, anyone else, that this is the a relative velocity question. And you've already told them that you know how to handle it because you're showing me the two speeds that you're taking in, 6 and 4, and you're also telling me that you're subtracting them and that the relative velocity is 2. You cannot take any shortcuts here. You can't go just vrel equals 2 because 2 is not given in the question. You did a calculation to do it. Therefore, you show me the calculation that you got. It's so simple. So that's why I box that off. That is so important to do. Okay? The next thing to do is either get the distance or the time. Well, we know the distance, 150. That's how far apart they are, relative distance to start with. And it closes. It gets closer and closer and closer as they run. So the relative starting distance is 150 kilometers. No, meters. Kilometers, that'd be funny. At that point, we write down our equation, v equals d over t. I'm going to rearrange it because we're calculating for time because we have the other two. So time is equal to d rel all over v rel. D rel is 150 meters, and the speed is 2 meters per second, so that equals 75 seconds. And that will be the answer to A. Okay? Why is that the answer to A? Well, that's how long Nathan took to run the 150 meter separation between them at a relative speed of 2. He was 2 meters per second faster, and he had to catch up 150 meters. So if Nathan ran 75 seconds, how long did Michaela run? Also 75 seconds. Because the beginning of the question, Nathan is running and Michaela is running. They start with this relative speed and this relative separation, and they both run. So both of them run this time. So how far has Michaela run? So this is a separate question now. This is not totally different, but different in that we're asking for how far has one person run. So what do we know about Michaela? Michaela is running with a speed of 4 meters per second. How long is she running for? 75 seconds. So knowing the speed of Michaela and the time of Michaela, we can get how far Michaela has run. Notice that in this second section here, that we're how far has Michaela run during this time, we're only looking at Michaela's specifics. That's all we can do. We don't touch Nathan's, or we don't touch the relative velocity. So distance is velocity times time. Velocity is 4 times the time of 75, and that is going to be 300 meters. Oops, let's do it in green. That's what I've been doing. Oh, I missed. Okay, and that's the answer to B. We could just move on at this point, but there's more to this question that I didn't ask. Okay, There's more to this question than I didn't ask. We could ask, and I'm not asking you to do it, but you can just watch here. Part C, pardon me. How far did Nathan run? Okay, the distance of Nathan. Okay, we could do this logically. Okay, if this red object lady here called Michaela ran from here to here and it ran a total distance of 300 meters, and Nathan ran from here to there, it was 300 meters and 150, you would expect that Nathan has run 450. Okay, so you would expect 450. Let's check it out. Velocity of Nathan was 6 meters per second. The time of Nathan was 75 seconds. So distance is velocity times time, or velocity of 6 times a time of 75. 6 times 75 is 450. So the distance of Nathan checks on out. We're happy. You're working. There we go. Okay. So that's how you do a relative velocity question. You find the relative velocity when both of them are running. You find out how far apart they are, or the time, how long they did it, and then find out for the unknown. The unknown here is the time. That's how long they ran. It took them to run to catch up. Then it might ask how far did each one run and stuff like that. At that point, you go back to single type questions where you're not using the relative velocity. So it's only the time of each of them. Excellent. Thank you. Enjoy. Try all these questions.